we are going to be talking about rotations, and I got to jump back and forth a little bit because I can't do a rotation well on my iPad, nor can you do it incredibly well on your iPad. So do rotations. Excuse me, still talking. Do rotations on paper, okay? I don't care if you think you can do it great on your iPad. That's fine. I'm going to make you do it on paper. I want you to do it on paper. Just because I need you to have it down come quiz or test, and that's how I can evaluate if you've got it, is on paper. So I'm going to do some stuff on the iPad right now, but the rotation we're going to just do on paper. There is an example of a rotation in video form. It is not me in Canvas. So if you do need to go back and look at this, there's someone that does it very, very similar to me. I put a video in there of how it's done, okay? First thing you need to know, rotations preserve distance, angle measure, and orientation. So they have the same orientation. Remember we talked about what has the opposite orientation? Reflections have opposite. Rotations will always have the same orientation. So if you're naming it clockwise, you will always name it clockwise. If you're naming it counterclockwise, you will always name it counterclockwise. So I'm just going to give you kind of a picture. I should just take a picture of this picture. Hold on. This is the picture I would have drawn for you, but I wouldn't have drawn it as well. So I'm just going to put this picture up. I'll give you a little bit of time. Don't worry about... Like, the red is not part of the picture. The red is just saying you're always going to go counterclockwise. I will talk to you about that in just a minute. But if you are drawing the notes, if you're writing in the notes and you want this, you are welcome to write this down. I'll give you a second. Excuse me. Shh. Essentially, I'm going to do one of these for you very shortly. So you don't need to be super detailed if you are writing this down right now, because I promise if it's not great, you'll do one in a little bit that's a legit rotation where you're actually measuring things, and that one will be great. So if you want to just do a little sketch of this, that's wonderful. A rotation. Another word for a rotation is a turn, right? So like you turn a doorknob, that's a rotation. Like I said, it's always got the same orientation. So if you look at the two triangles that I have here, VUW and V prime U prime W prime, if you name them, you would be going the same direction for both to show that you have the same orientation. So VUW, you're going counterclockwise. V prime U prime W prime, again, going counterclockwise. So that's how we know they have the same orientation, is we name them the same order, the same direction. And like it says there in the red, with a rotation, when I ask you to do a rotation, you will always go counterclockwise. Okay, unless they specify otherwise, your rotations should be counterclockwise, meaning that's this way for you guys, right? Yes, yeah. Counterclockwise, okay? So turning to the left, essentially. Here's what you're doing. You're going to rotate around some point. So in this case, that is point Q, is the point of rotation. So when I rotate around that point Q, if I draw a line to V, my angle of rotation is here. Whatever angle I make here is my angle of rotation. So say I wanted to rotate 50 degrees, okay? I would rotate 50 degrees to get to V prime. I would rotate 50 degrees to get to W prime, and I would rotate 50 degrees to get to U prime. So you kind of do the same process 3 times in a row. And I will show you that right now so that it makes sense. But before I do that, I want to just show you the notation for a rotation. We talked about a translation. Notation for a rotation, yes. A translation was a capital T, right? A reflection was what? A capital R, okay? A rotation is a lowercase r, yes. So this is how I would write this, okay? For this scenario, I would say we're doing a rotation, And then your subscript here, okay, your slightly smaller lower, is, like we said here, x degrees. Let's pretend I didn't put the 50 there. So whatever your degree measure is, and then always the point of rotation. So whatever I'm rotating around, which in this case is Q, okay, so it's a rotation of x degrees about point Q of triangle UWV, I think is what I said before, maps onto triangle U prime, W prime, V prime. Can we what? Oh, I thought you were talking to me. So this is how you would write the rule for a rotation, okay? Lowercase r, the angle of rotation goes here. The point of rotation, so whatever you're rotating around, goes here. That is not the right word. I wrote ration instead of rotation. Okay? And then the triangle you're rotating and the triangle it becomes. Okay? Okay, so we're going to do a rotation. If you need to watch this, if you're watching the video, go to the other video. Sure. Okay. I know, but it's good. You got to practice it. Here it is. And they go really fast once you get it down. If you are doing a rotation in the coordinate plane, okay, there are a couple rules that just kind of help you do it quickly. So if you have to do a rotation of 90 degrees about the origin, right? O is the origin, okay? Whatever your point is, so say it was 3, -5, okay? If this was 3, -5, if you rotate 90 degrees around the origin, your point will always become a -y x. So if it was 3, -5, a -y would be what number?
-1.
-y. What is y right now?
0.
No. If I'm rotating, if I said this point, what's y? -5. So what's a -y? +5. So if this was 3, -5, your new point would be a +5, and then x stays x, so 3, right? So you can just take whatever point you had, move them, switch the direction, or switch their placement, and then make the first one the opposite of what it was. Okay, make y the opposite of what it was. Okay, so that's if you rotate 90 degrees. If you rotate in the coordinate plane 180 degrees around the origin, whatever xy was will become a -x and a -y. So this one, you just make them both the opposite of what they were. So if it was 3, -5, like we started with up here, my new point, after I rotated 180 degrees, would be a -3, +5. So you're just changing the sign of those numbers if you go 180, okay? And then the last one, if you rotate 270 degrees, so in other words, you're going 90 degrees clockwise instead of 270 counterclockwise is how you could think of it. Whatever your x and y are will become a +y, or the opposite of, whatever your y was, and then the opposite of whatever your x was. Okay, so I'm just going to show you on a coordinate plane here what that looks like. So you know what I'm talking about here. Okay, so let's say you start at point G, which is at 4, 2. Okay, so point G here is 4, 2. Okay, if I want to rotate that 90 degrees around the origin, so here's my origin, 90 degrees, we always go counterclockwise. So this here needs to be 90 degrees when I rotate it. Instead of having to like really think through where would that fall, you can look at your setup, whatever it was, so in this case 4, 2, should become a negative y, or the opposite of y, and a positive x. So what is the opposite of y right now? Negative 2. And then what would your x be? Which is really your y. 4, right? So negative 2, 4. So negative 2, 1, 2, 3, 4 would put a rotation of 90 degrees right here. Okay, so this would be 90. Okay, if you want to go 180, the nice thing about 180 is it's going to form a straight line, right? 180 degrees is a straight line. So if you want to go 180, and we started with 4, 2, what's the 180 rotation going to end at? Negative 4, negative 2, right? So negative 4, 1, 2, 3, 4, negative 2 puts you right here, right? So this is 180 degrees. It would be a straight line at negative 4, negative 2. Okay. If I wanted to go 270 degrees and I started at that same point, 4, 2, what would the new point be? Right, so the y value is still y, it's just in a different place. And then the x value is now the opposite of that, a negative x. So it was a positive 4, so it's going to be a negative 4. So 2, 1, 2, 3, 4, 2, negative 4 is here. Okay, so this angle right now is 270. Okay, that's a rotation of 270 degrees, which is actually 90 degrees the other direction. Okay, so those are the rules that go along with it. I wouldn't spend a ton of time memorizing them. I don't do a ton with it, but it is good to know just to keep things simpler when you're trying to find a missing piece. Okay, questions on that? Oh man, we're gonna run out of time. All right, so let's do last thing here. Sorry, that last one is going to be our example 2. This is example 3. Let's say I have a hexagon. You all right?
I'm sorry, everyone.
All right, let's say you have a regular hexagon. So all the angles, all the side lengths are the same in this hexagon. If I want to rotate around point X, I want to know what is the angle of rotation from point B to point F. Okay, so point B is here, right? And we go clockwise or counterclockwise? Counterclockwise. So we're going this way until we get to point F. I want to know, what is this angle? Do you have any idea how you could find that?
You put it on your protractor and you count.
Without using your protractor, how could you find it?
So you
Find it
could,
between A and double it.
well,
You could, but without using your protractor, how would you find A?
Oh, wait. Well, to E is 180, so divide that by 5 times 2.
You could do that.
you could.
By 6 and times 2. Or this is a circle, right?
Yes, it is.
So 360 degrees, okay? And there are 6 of these equal angles in the middle. So 360 divided by 6 is 60 degrees. That means this angle here is 60. This one is 60. This one is 60, right? Those are all 60-degree angles. So you just do 360 divided by the number of sides. This is a hexagon. 360 divided by 6 gives you 60-degree angles. What is the angle then from B to F?
You just add the 2
add the two together, right? 60 plus 60. So from B to F would be 120 degrees. Okay? Questions on that? Okay. That's all we got.